right, AP Environmental. This is our first lesson here from home for the next couple of weeks. So again, just make sure that we're checking our agendas on a daily basis. The COVID virus has struck my family, so including me. So I'm going to be making things kind of short. I'm not going to have the energy to, give you guys 45-minute lecture notes and stuff. I will make these things kind of short, maybe 10, 15 minutes a piece, and then we'll do a little bit of buzzwork each day, but not too much. So anyway, so I want to talk a little bit about population math today. The assignment I'm going to give you today, you will need a calculator to use it, but just kind of looking at populations in general. In this term here, demography, which is the study of human populations and how they change and their trends and things like that. We're going to look at four different things the next couple of days. We're going to be focusing on this first one today, which is changes in population size. That's part of demography. I mean, the understanding that populations are not fixed. I mean, they're going to be changing all the time, and how they change, and we can actually predict, what population sizes are going to be if we know a couple of factors. Fertility rates, we'll talk about that more maybe tomorrow or even into next week. Life expectancies and also age structures are something that, again, all these things kind of fit into demography and the study of human populations. All right, so I want to talk a little bit today about, again, population size and how they change. The other day, last week, I think I mentioned a little bit about these inputs and outputs. If populations change, then there's going to be kind of an imbalance of these inputs and outputs. The inputs are immigration and births. That's how individuals come into a population, and the outputs are emigration and deaths, which are the ways that individuals leave a population. So you make sure we know the definitions here of immigration and emigration. This term here is called net migration rate. It says it's the difference between immigration and emigration in a given year per 1,000 people in a country. So, for example, let's just say there's 1,000 people that live in a country. There usually isn't, but let's say that there is. And let's say 50 people come in and 40 people leave, right? So there's a difference in 10, right? There's a plus 10 difference there. So that means the migration rate would be a positive, right? Because you'd have more people coming in than would be leaving. Sometimes you get a negative migration rate. You get more people that leave than come in. I mean, there are countries around the world that have net migration rates that are negatives because way more people are leaving than are coming in. Now, think about the United States. We definitely have a positive migration rate. In fact, some people might say that it's too positive. Like we have too many people coming in. That's why we need to strengthen the borders and all that type of stuff. But that's a topic for a different day, maybe even for a different class. But migration rate again is what it is. It's the difference really in people coming in versus people leaving a country. All right. Now for the math. I'm going to give you guys a couple of formulas today. You are going to have to know these. I'm not going to give them to you on quizzes or tests. But they're actually pretty easy to use if you just kind of practice them and kind of study it. The first one is called crude birth rate. And it says here it's the number of births per 1,000 individuals each year. So in order to figure out the crude birth rate, you just have to know how many births there are. Okay. You have to know the total population size. So if you know those two things, you just divide them and then multiply it by 1,000. And the same thing goes for what we call the crude death rate. Crude death rate is how many deaths per 1,000 individuals every single year. So again, if you know how many deaths there are and you know what the total population is, just divide those two things, multiply it by 1,000, you'll figure out your crude death rate. Now, to kind of put this into perspective and kind of look at, worldwide at least, where we are when it comes to crude births and crude deaths. The crude birth rate globally is about 20. ish. It's like 20 point something. So that means for every 1,000 people on this planet, there are 20 births, okay, every single year. Now, the crude death rate globally is about 8. So again, for every 1,000 people, there's 8 of them that are going to die every single year. So if you just kind of look at those two numbers, it really they don't really balance each other out. I mean, one of them is way higher than the other one is. So what this is telling us is that there's a lot more births per 1,000 people on this planet than there are deaths. Remember the other day in the video when I showed you that population ticker, right? And how that number just kept going up and up and up and up, right? 7.8 billion people right now, right? Well, the reason why that's happening is because of these two numbers. Now imagine if, those two numbers were exactly the same. If the death rate was exactly the same, then that population ticker would stop. It wouldn't be going up anymore. But the problem is it is going up, and it's because these two numbers are not in balance. So I guess we have to look at one of two things. Either one, bring down the birth rate. I guess we can also bring up the death rate, but I mean that's kind of cruel. I think the key to getting these two things in balance is to lower births. We have to find ways globally, to limit people from having so many children. That seems to be the only way that we can stop that population ticker from continuing to go up at the rate it's going up. All right. Now, if we're going to figure out a growth rate for, let's say, the planet, if we want to know like like what the growth rate is for like the whole planet Earth, that means all the countries together, all the nations of the world. All we have to know is crude birth rate and crude death rate. We don't have to know anything about migration because nobody's migrating off the planet. Nobody's immigrating here from another planet. So migration doesn't even come into account. So as long as you know the CBR and the CDR, then you can just use those things and figure out what the growth rate. And there's actually one of two different formulas that you can use. I like to use this first one. I think it's really easy. Just take the CBR minus the CDR and just divide it by 10. And that's going to give you what your population growth rate is going to be. Or you can do it this way. Okay, either way, you get the same exact answer. So let's go ahead and take those two numbers that we had earlier, right? Because our global crude birth rate is 20, our global crude death rate is 8. And if we take those numbers and we plug them into this formula, we get 1.2%. So what that's telling us is that the population of the world is growing at a rate of 1.2%. And that may not seem very high, but again, go back to that population ticker that I showed you, and you saw how rapidly it was going up. That's all because of this number right here. If that number were lower, then the ticker would slow down. If that number goes higher, the ticker speeds up. All right. So, kind of one of the biggest things that we have to figure out, I think, as a planet, is how do we lower that number? How are we going to do it? It's not a very easy solution because there's a lot of other dynamics that come into play, especially when you go from country to country. There's things like religion that come into play, education comes into play. There's a lot of other factors that really contribute to that number. Now, if we're looking at an individual country, then we have to look at migration and crude births and crude deaths. We have to look at all that stuff because in a country, you do have migration, right? So let's say, for example, that it says here we have a small country of 750,000 people. It has 45,000 immigrants and 15,000 emigrants. That's per year. They also experience 15,000 deaths and 35,000 births. What's the growth rate of the country? Well, you'll notice that this formula here Again, you're going to have to know these. I'm not going to give them to you. It takes into account the inputs, right? Births and immigrants, and it also takes into account the outputs. So if you know all those factors, and you do know them all in this problem here, then we can just plug those things in and we can solve. So there's 35,000 births, right? There was 45,000 immigrants. There's 15,000 deaths, and there's also 15,000 immigrants. So you just do the math there, divide that by 750,000, times it by 100, you get 6.7%. So this particular country has a growth rate that is much higher than the world average, right? We said in the previous problem that the world's growth rate was 1.2%. This country is 6.7. And I'll be honest with you, there are countries around the world that have growth rates that are like this. So I think one of the keys to lowering our global growth rate to that 1.2% is we need to pinpoint some of these countries. We need to find out why their rates are so much higher than others are. And if we can figure out and help them lower their growth rate, then maybe we can solve this global crisis. But again, there's a lot of other factors that come into play. All right, last thing here is doubling time. We've talked about this before. If you know the growth rate and assume the rate is constant, even though growth rates are not really that constant, we can assume that they are, but they change and fluctuate all the time. We can calculate the amount of time it takes for a population to double. So let's go ahead and use our doubling time formula, which is 70 divided by the growth rate. And let's use this and let's apply this to our global growth rate, right? We said earlier that the growth rate of the planet is 1.2%. So if we take 70 and divide it by that growth rate, what this tells us is that and this is kind of scary, the population of the world will be doubling in 58 years. So in 58 years, you guys might still be alive. I'll be gone. Hopefully, if I survive this COVID, anyway. But in 58 years, the whole planet it's going to double. So if we've got 8 billion people right now, I mean, we're looking at over 15 billion people, in less than 60 years. But again, that's assuming that this growth rate is not going to change. Now, they do predict, a lot of scientists predict that 1.2% is going to go down slightly, in the next, whatever, 15, 20, 30 years. And if it does, then, that 58 years will be longer. But I mean, we're going to have to really focus and think about ways that we can get that growth rate down so that we can extend our doubling time, right? We don't want to double the population of this planet. I mean, that's going to be kind of a scary thing. All right, guys, that's it for me for today. Thanks for hanging in there. Check the Buzz agenda, and I'll talk with you soon. Bye.